This conference will now be recorded.
Hi, very good morning and good evening, everyone. Welcome back. So just try to look back in last week what we were trying to do. So we'll just trying to do this, right? So we have talked about certain things of Terraform, and yeah, so I think we're just trying to talk about the basics of Terraform, and we're just moving from there. Yeah, all right. So let's continue the same part. All right, so let me just connect. So the next thing which we're going to talk about here is modules. 0506 modules. All right. So, but before to that, let me do one small thing. Let me bring up my workstation. I think in the last session, just to recall, so we talked about how do we create the resources, and also we deal with how do we deal with the remote state is what we have discussed. Okay, so we're going to continue, yeah, with the modules. And why module? What is module? Okay, we'll talk about that particular one now. Okay, my workstation is running from a long time. All right, that's okay. Cool. And so the next thing is, here is, go here. New file, something like module.tf. Now, what is a module basically? First of all, before entering into the thing, so module is nothing but a group of resources. If you want to group the resources, okay, and you want to create them as a set, like in shell scripting, it's a function, right? So here use a function like something like that. So here you are going to use module, okay, nothing but. When you call the module, so all the resources will be created. So that's the idea of having a module. So having a module will help you in decoupling your code and help you in reusability as well. I mean, keep your code dry, and at the same time, also it will help you in reusability. Like let's say, so in one project you have made that module, so probably you expect the same module to be run for another project also. It's a kind of helpful. So reusable, it gives you a scope of reusability. Okay, so that's a major advantage you're going to get it through a module. So otherwise, it's a simple group of resources. We're going to group the resources with module. Okay, so how do you create this particular module? All right, so module, and I can just say that your module can be first of all a local directory. So I'll just say that it's a module, one, And also another directory I want to create it, new directory. It's actually going to be module 2. Okay, so new file, and then I'll go for let's say some file, main.tf, whatever it is I can call it as. The tf file is your choice, file name is your choice, main.tf. So there are 2 files I'm making it here. In the modules, I'm going to write a module, so saying that module, so module, basically module 1, and the source is actually /module1. Okay, so here is your module, you're calling it this, and the code inside here is going to be getting executed. All right, so that's all and nothing more than that. Okay, so for an example, if I want to show something like I want to create some instance, okay, so probably we can just take that information from here. Just take the instance, that much. All right, so I want to create an instance. Git pull, so cd06 modules, so Terraform init, and Terraform apply hyphen auto hyphen approve. So region is missing. Of course, the provider information is missing. So the provider AWS, and then region is equal to US hyphen east hyphen 1. Git pull. And then Terraform apply, right? So that means what happened, you have one resource and that particular resource has been created. It's been calling it as module name AWS instance sample. Okay, so that instance is getting created. So the list of resources, whatever you have mentioned out there, will start getting created over here. All right, so let's say if I just make another resource, like let's say I want to create 2 servers, sample 1, and now I'll just go and say that and git pull. Now there is a change in the module. There's a change in the module. So the source module, whatever you're doing, is some change. Now let's see how it behaves. Yeah, you see this, it's working fine. So instance refresh. I mean, refreshing the instance, refreshing the state of the existing instance and creating the new instance, which is fine. And that happens over the state file. You know that anyhow. All right. So now the thing over here is, I wanted to talk about what are the sources of modules you can use. Okay, so module sources Terraform. Okay, what are the different sources you have in Terraform modules? You can give the local paths. So that's what I have done. / and I have given the path and it is working fine. That is the local path. Okay, and you can use Terraform registry. Okay, Terraform registry is nothing but Terraform is going to give you a lot of predefined modules. Okay, if I go for registry.terraform.io, let's say you have a very generic requirements. Like let's say I want to create some kind of so I want to go with AWS. So if I want to create some VPC is a very common one. If I want to use that, I'll just go there and I'll say that, so I want to use this particular one. So that's it. And you're going to create it. So you're going to say that a module and it's a VPC and this is a module name you're giving, and you're giving certain inputs to that, and that module will be called and created. Okay, so this is how you're going, you can do the registries basically from the Terraform registry, which is someone has written that code and you're going to call that particular code. That's it, nothing more than that. Someone is writing the code and you call that particular code. Okay, so you're using some, okay, So you're using some predefined code of someone's. Okay, but technically talking about in projects, you cannot blindly use that way. So sometimes, so it cannot be, not sometimes, usually, most of the times it cannot be exactly useful. You have your own customization. So that's where public code, you can only use it for reference generally. And so, or else you're just trying to do some kind of a hello world applications kind of thing. So things might work, but getting into the project, you can never use the same code. Okay, so that you have to keep in mind. And so the next thing is, either you can keep your code in GitHub, and you can do that. Okay, so keep your code in GitHub, and you can say that I can just go with the GitHub and use it. Okay, so if it's a GitHub, you have to give the GitHub and you give it automatically. It calls that particular GitHub module also. Okay, so modules also it can call. And what else? If you want to queue some Bitbucket, because Bitbucket is also a Git repository which is provided by Atlassian. So if you are keeping under like GitHub, you have Bitbucket also. Like GitLab, you have alternatives. So GitHub and Bitbucket. So two are different sources of who provides Git as a repository service. Okay, or else you have a generic Git or Mercurial. Mercurial is a old kind of repositories like Git. Now, if you have some Git also, your company can have an internal Git repository. So somewhere, if you want to use that generic Git also is possible. Or else, okay, so you can use HTTP URLs. Okay, you can give HTTP URL and say that so Terraform get something, and if you have some so code hosted in over a web server, if you want to call that also, it is possible. And finally, you have some S3 bucket also. If you're keeping inside your code in S3 bucket and you want to call that in from the S3 bucket also, it is possible, and it actually has to be in a zip file format. So that is one thing. And GCS is nothing but Google Cloud. Okay, Google Cloud storage. Like Amazon, you have S3, and Google Cloud also you have GCS. So these are the different sources you have. You can provide as a module. Okay, it is your choice. Okay, so which one you choose. So probably in organizations, I cannot use GitHub or Bitbucket, so something like that. So the alternates I can use is generic Git. Okay, so that is one if it is in a Git repository, or yeah, so if it can be some S3 bucket also, it's okay. And even I cannot use Terraform registry, so all I can use is local paths something, and I can use some generic Git repositories and even S3 buckets in companies environments. Okay, so like let's say in a closed environment, I don't expose the code of my company to the outside world, right? And again, that depends upon their business again. So yeah, so keeping that in mind, so yeah, I'm just using local path. If I'm using a separate Git repository also, I can use that. Okay, so simply give that particular Git path, which is also works fine. All right, so this is how we create a module, and it's a module sources. First thing we talked about module source, and this is a source. And to the module, you can send some data. Okay, and module can read that particular data. So how do you send that is so simply like this. So like let's say instance underscore type is equal to t2.micro I'm giving. Okay, so it's hard code. Like let's say t2.micro I'm giving. Okay, so this instance type should read from here in the module. So module should be having a variable, this particular module, and over here I'm going to say that it's var dot instance type. Okay, so one instance basically. And okay, so this is how you can send some data to the module. You're sending to the module, right? So git space full Terraform apply. So it is modifying because there is some instance change, and it is modifying now. I think you'll get it anyhow. So it's going on. Now you're sending the information to the module. Now you want to grab the information from the module. I want to get the information from the module. So then I can, what I'm going to use is output. So then I'm going to say that, so public underscore IP. Public IP is nothing but is actually going to be is AWS underscore instance dot sample dot public underscore IP. Okay, so you're going to send that information, but it will not print it now. Output inside a module will not print on the screen. Okay, let me show you that. Output inside a module will not print it. So I'm just using a git pull, and I'm going to enter Terraform apply. So you see this, it's nothing printed. So it pulled the code, but still nothing get printing on the screen. Okay. So what actually you have done is you have sent some information from the module and to the main module, which is also nothing but called as root module. Okay. Now there is a terminology. So the main code is called as a root module, and your module is called as a submodule now. Okay. Now the submodule send the information to the root module. That's it. Now it's the root module a decision to do what it has to do. Okay, like let's say if I want to print some output, so I'll say public underscore IP. You can give anything, but the data is coming from module1 dot public underscore IP. That's it. So you're actually taking the public IP. So the root module, if you use the output inside the root module, that it is going to print it. If you use the output inside a module, submodule, it is actually going to share the data to the root module. So that's the difference actually you're going to get it. Now you do the git pull and you're getting this. So now the output, whatever you know so far, is little different inside a module and little different inside a root module. Make sense? And also you can send the information from one module to another module. Like let's say I want to send the information now these two, like let's say, and I want to, so put that particular public IP content in a file, like let's say, okay. So in a file, if I want to give, there is something called as, so file, no, what is that? Render a file, Terraform. Template underscore file. So there is, no, I'm just, there is another module as well. So Terraform, create a text file, local underscore file, yeah. So local underscore file is another another provider which is available. So using that particular file, I can create a file. Now let's say in this particular module, I want to use that. Okay, so local file. So who I'm calling it as the content is. Now let's say this is a module. You're actually going to collect the data from one module. So module, and it's actually going to be module 2, and it's going to be /module2 now. And so now I'm going to send the information, which is public underscore IP is equal to module1 dot public IP. You're sending that particular information. So now take this public IP and go here and you say that variable, you're putting that particular value. Okay. And so now actually I'm going to say that so /tmp/ public IP dot txt file. Okay. And what is the content I'm going to say that is so it's actually going to be var dot this one. All right. So this is the much I want to make it. Okay, so let's see now what happens. Now there is a new module. So there's a new module. You have to do the Terraform init for initializing the module, and the modules will be initialized during the Terraform init phase. Init phase is actually initializing the module. Now if you just go for the Terraform apply, it will not work as expected. Okay, you see this module not installed. So run the Terraform init first. Yes, of course. So Terraform init, and so it actually initializes the module 2 also, and the Terraform apply auto approve. So now cat/tmp, so now you have public txt file, so you have the same IP address 124 here, right? So that's how you're sending the information from one module to another module also. Okay, now there is a dependency. Automatically it is running the first module and then it is running the second module. You see this? Because there is a clear dependency between them. Okay, if you don't have some dependency and you want to enforce the dependency, then you go for depends on, which is module.module1, depends upon this module.module1. If, like, let's say you have given a relation here from this module to this module, but sometimes you cannot do that, so you have to enforce the relation. So this has to run definitely after this, then you go for depends on. I already explained this particular one, right? So these are the things which you have inside modules. Okay, and so yeah, I think that's all in modules. Any questions? Any questions on this? All right, so if questions, the next one is going to be something called as there is something called as let me. Okay, so we are just trying to talk about providers, resources we talked about, and that's okay. And Terraform state file, remote state file, Terraform modules. So what I'm mentioning is a module is nothing but a group of resources. It helps you in keeping your code dry. And in Terraform, everything is a module, and the main code is called as a root module. Yes, from Terraform 0.13. So that depends on option whatever I have mentioned. So this is available only from 0.13. If you are using 0.12, that depends on is not available, and also there is something called as a count keyword. We'll talk about that. So that is also not available if you are using before versions of Terraform 0.12. You cannot share the data. You cannot share the data from one module to another module directly, but you can done only through the root module. Okay, so you can done only through the root module. That means actually this module inside this, it cannot call actually. It cannot call saying that so this data is a module.module1. It will not work. Okay, so it has to go through this guy only. So that's the important point as well. Okay, so the next one is I think there is still certain more topics we have here.
So Raghu, what's the best practice then? There should be always a root module.
No, it's not best practice. That's the only way that Terraform works, right? So that's a way of Terraform working. Yeah.
Okay.
Yeah.
So
you don't have an option. It's not a best practice. That's the only option how the Terraform works basically. Yeah.
Gotcha. So yeah. I mean, so anything that we are anything that we want to call in subordinate modules like module 1, module 2, it's better. Okay, got it. I think I got it.
Yeah. So the next couple of things which you have is conditions and loops. Okay, let's talk about that, and then we'll go with the other two things, and then only we'll go with the thing. So the next thing which we're going to talk about here is conditions. Okay, so Terraform conditions. So conditions are not typical conditions like how do you think in normal scripting language or programming language. So conditions in Terraform are used to determine whether a resource can run or ignore. Okay, that's the only purpose of the condition. Okay, the conditions in Terraform, okay, is the conditions in Terraform is used to determine whether you want to run a resource or you don't want to run the resource. Okay, that's it. Okay, that also with the help of I think better we should be talking with the I'll talk about the loops here. So first, loops is the important thing because conditions is directly dependent on loops. Okay, so I'll go with the loops. So loops in Terraform help you to create multiple resources using the same resource block by iterating it. Okay, so loops in Terraform is going to help you in create multiple resources using the same resource block. You're going to write the same resource block, but you are going to just iterate that. Okay, so how do you do that? So like, let's say resource, so like, let's say AWS underscore instance, and you just say sample. I think you can just better copy the code also. Okay, so something like, let's say var.am, something like this. Okay, so now here, and I'm going to give count is equal to 3. Okay, so something like this. Okay, so I'm just doing this now. The loop in okay, so keyword count will tell to the resource so that how many times it has to iterate. Okay, so you're going to have count equal to 3. That means how many instances is going to happen now? 3 instances are going to happen. 3 instances are going to happen. So previously you had written 2 blocks of writing the code. Now actually you want 2 servers. Then you have to delete that and say that, so count is equal to 2. Okay, so count is equal to 2. So that's what you're going to do. Okay, so previously you have written 2 resources. Now we are not going to write any more 2 resources. We're going to say that count equal to 2. So we're going to iterate that by using the count, by using the keyword. Okay, keyword count. Okay, so count offers index. Okay, count offers index and can be that index can be referred as count.index. Okay, so that can be referred as count.index. All right, so what is this means is now let's say count for the first time, the count, so there are 3 instances, right? The iteration 0, iteration 1, iteration 2, or iteration 1, iteration 2, iteration 3, right? But here the index starts from 0. Okay, that's what we have to keep in mind. So index start from 0. All right, so what is this means is now there are 3 now you are creating 3 instances, right? So now like, let's say every 3 instance is actually going to have a different AMI, like, let's say. Okay, and AMI is a list. Then what you're going to do is now list how you're going to access the value inside a list, where dot that particular list variable of 0, of 1, of 2, like that, right? So count.index I'm going to give. All right, so this is how it is going to help you in the indexing. So that means now I have 3 instances we have mentioned, and in these particular 3 instances we have created the 3 instances, and so, and I have a 3 AMIs which are available, and we have 3 AMIs which are available. Now if I want to so pick one by one value, and I want to apply a new AMI for each and every instance, then this count.index is the key value which is going to, key parameter which is actually going to play a role here. Now count equal to 3, not every instance is with the same AMI. My requirement is every instance should go with a different AMI. Now I have an AMI which is a list out there which is having the list of AMIs. Now I'm going to say that count.index. So first time it's going to pick the first AMI, second time it's going to pick the second AMI, third time it's going to pick the third AMI. So actually this count.index is a quite important thing when you make actually the count. Okay, so the count equal to 3 instances, or it's going to iterate 3 times. Now it actually going to pick the 3 values from the list. Okay, so that is how it is actually going to be that is how it's actually going to be working. Okay, all right, so this is how you have loops. Okay, so as I mentioned, so so starting from Terraform 0.13 version count is available for module also. Okay, this is a quite important thing, because earlier days it was a pain basically, so we cannot actually iterate the module. The module need to be run for 3 times. I have to declare it 3 times. I do declare it 3 times, or I go with some kind of automation from my side to iterate from my side. Okay, so that's what we used to do. Either you write your own logic, kind of wrapping up with some shell script, and you can iterate that. I can show some examples which I have in my so cd repos. So back in days, I don't have any of this kind of what we call module iteration. So this is an year back project. So, and I can just show that. I think a platform. No, I think I'm wrapping it somewhere. I just went to the module. No, I have to go to the dev environment. Yeah, where it is. So now you see this. There is some shell script. Yeah, launch infra.sh. Now you see this, since I don't have any kind of module iteration, so but there are a hell lot of modules available for me. So I'm just iterating with the help of a module basically here. So now if I just, so I'm calling the main module, main function from the case command here. And if I go for main, actually you see this. So for installation in the list of installations, I'm actually generating the module. So echo module. So if I run this, what is actually going to happen? It actually generates some kind of module format. You see this? It's actually generating module onboarding, and I'm putting this module is actually this, something like this. This hyphen is missing because this is an installation variable that comes from this, okay, from the script. Okay, but you just understand, so I had a, so we don't have that kind of option directly from the Terraform. So I went with taking the help of some shell scripting, and I'm wrapping with shell scripting, and I'm doing that. But right now I don't need to bother about that. Okay, so I can just iterate as my Terraform itself directly giving that particular option. So that's the idea. Okay, so and yeah, so that's the thing. You have it in Terraform. Loops, I don't think so you have much options around the loops. All right, clear? Any questions? Now, technically talking about, okay, so technically talking about this one, so which is Terraform conditions. Conditions is directly dependent on conditions. So conditions directly dependent on your conditions directly dependent on your loops basically. Okay, condition to make sure that so this count equal to 0 or count equal to 1. So when I say the resource, if I create a resource and if I say that count equal to 0, so that means that resource will never get created. So that means you're skipping the resource, right? So that's what I mentioned. So Terraform, so conditions in Terraform, conditions in Terraform are to just determine whether a resource can be created or not using count keyword. Using count keyword, you're actually trying to do that. That's it, nothing more than that. Okay, so you're not doing anything more than that. Using a count keyword, you just tell that whether that resource can be created or not. Okay, but how do you specify the condition? Okay, so how do you specify the condition? So conditions in Terraform, you're going to write the little bit conditional expressions. So this is how you're going to write it. Okay, so your condition, true value and false value. Condition, true value and false value. So that is means okay, condition, true value and false value. All right, condition, true value and false value. All right, so here true value, false value. Okay, and yeah, now if the condition, if the above condition is true, okay, let me put this. If the condition is true, then picks true underscore value, else it picks false underscore value. Okay, so in the above example, basically the condition is true, okay, it picks the true value, and if the condition is false, it's actually going to pick the wrong value. So I'm just going to comment out this, and let me take another example. So if I say that here count is like, let's say var dot like, let's say var dot count var dot count var dot so create, like, let's say var dot create is something like so we just say this var dot create. So like, let's say a variable create is there. So now, like, I can say that so variable create, and I'll say that default is equal to true. Is a boolean I'm giving. Okay, so default is equal to true. If I just give this something like this, then this is going to become like this. So variable create default is equal to true. So that means create is a capital, making it here. So I'll just say that it's a create. Okay, so now this variable create is true. So that means the condition is actually going to be this is a commenter line. So var dot create, if this var dot create is true, directly you're saying that so now the true value is actually going to say that it's actually 1, otherwise it's actually going to be 0. As simple as that. Okay, so now like this I'm going to put a condition. So now if I say that var dot create is equal to 1. So then this is going to be like this. Or sometimes you make it something like, so related to the environment. So if it is a dev environment, do that. If it is a prod environment, don't do that. Or if it is a prod environment, do that. If it is a dev environment, if it is a dev environment, you do that. If it is a prod environment, or if it's a dev one environment you want to do, another environment you don't want to do. So how do you do that? Okay, so there is something also you can just say that. So something like this. Okay, so I will just say, all right, take this as here, put it here. I'll just put comments here and I'll make something here, something like this. And like, let's say count is equal to like, let's say var dot env is equal to, okay, if it is equal to dev, then if it is equal to really dev, then question mark. If it is equal to 1 or 0, or if it is equal to prod, then make it 1. Or if you have to only 2 environments, or you will just say that prod, if it is equal to prod, then true, make it true. If for other environments, just make it 0. Okay, so that's the idea I'm making. All right, it's up to you how do you make the logic. That's it. But you are controlling that particular one mostly whether to create the resource or not by using this count. Okay, majorly. That's it. Nothing more than that. Okay. And also, it's not only for okay. It's majorly. It is majorly. So used with count, but can also be used with any argument. What is argument? I already shown you, right? In resources, argument versus in resource, argument versus attribute. What is argument? What is attribute? Argument is nothing but the input you provide, like AMI. Okay, so AMI, if you want to use with a a condition, you can still use that. No issues. It will work. It will work. So yeah, you can use it with any argument as well. Not only for count, but it is majorly used with count. All right. So this is the idea about conditions. Okay, so that's what you're having it in Terraform. Conditions. Clear? Any questions? Any questions, confusions?
So going back to that module example, I mean, if in module 1, if in module 2 I want to call something from module 1, it has to go through the root module.
Yeah. All right. So the next thing, which we have here is we call conditions are extended for variables also. Okay, whenever you are actually reading the input from the or if you're actually expecting a variable, and okay, so Yeah. So where is this variables? I think I'm running unnecessary servers. Let me destroy them. And yeah. So coming back here. So Terraform variables. And if I come bit down, yeah. So basically, we cannot actually call it as a conditions, but yeah. So it's yeah. So actually, the validations. Let's put this something like a validations only, rather than just calling it as conditions. Put like so Terraform variable, validations. Okay, so yeah. Now here, what is the purpose of this? So sometimes you take the input and the input is expected something and the user might give some wrong input. Okay, so you need some validation there. And so that particular validations are generally called under the variables like this. Okay, so this also you can, and this also will not, sorry, this also could be falls under something like the conditions, but yeah, so you can just call it as a variable validations. And so in this particular example, so they are actually expecting the string, and so what it is image ID. Image ID always definitely starts with AMI hyphen, right? So that's the minimum check that they're trying to check. Okay, and what they're actually doing is the length of, okay, so the length of var.image ID. So what is the length actually? Length is a functions. Okay, so length is nothing but a function. Okay, so we are using the function here. Okay, so we're going to use functions. And again, I think before to this, probably I need to talk about something called as a functions. Okay, so let me add some something like, so Terraform functions. So Terraform functions. So functions are inbuilt function, okay, what we call inbuilt Terraform. So the Terraform, language. Okay, so Terraform language includes inbuilt functions. Okay, and these particular functions are okay, or basically inbuilt, as I mentioned. So functions are inbuilt in Terraform. Okay, so we cannot create any functions as a user. Okay, user of Terraform. So you're just a user to the Terraform, and you cannot actually make anything on your own. Okay, so that's the Terraform functions basically. So these brings some common programming functionalities like like let's say so like let's say convert to uppercase, something like that. Okay, so convert a string to list, or so cut a string, something like that. Okay, so concatenate okay, concatenate a string. Okay, or probably add some numbers, add some numbers, so something like that. You just generally, so it just brings those particular functionalities, like any programming language. So generally brings certain functionalities. Okay, so in build you'll be having certain things. Okay, so so the Terraform also brings the same thing in the name of functions, and yeah, so it just does that. All right, and and the next thing is and the next thing over here is so yeah, as it mentioned in the documentation, the very important thing is so general syntax of the function name followed by comma separated arguments in parentheses. Okay, this is the common one. So that anyhow with the practice you'll understand that. So not a critical point, but still, yeah. So function can be used with arguments. Function can be used with arguments. Okay, and then function can be used with arguments in resources and modules also. You can use that in resources and as well as in modules. Okay, so that's the idea. And so that means if I say, just like let's say, so I want to convert into some new directory, let's say 07, let's say functions, I'll say that it's a simply like so sample.tf, something like that. Bring it here. And over here, so this is tags is equal to, I want to put a tag, and I like let's say here I'm just giving variable name is nothing but default is equal to like let's say sample. Okay, so now I want to put a tag, name tag. So in a very standard, all my nomenclature I follow is capital letters. All tags I'll follow is caps. That's my standard. Like let's say if user gives a small characters also, I'll put it into caps. Then how do I do that? So basically upper of var dot sample. That's it. Var dot name. Sorry, var dot name. Okay, so this is how you're actually going to do the things. Now that particular instance will be created. Now the so now the input is given as sample. That sample will go into capital letters and will happen. Okay, so cd07. So Terraform -auto. So region here's -east -1. Now it is going to try to create an instance. So now you see the sample all coming in caps. Okay, like that you have a lot of functions out there. So based on your requirement, so you just explore those particular, at least 100+ functions are available here. Okay, a lot of functions, number related functions, string related functions, collection, including like this certain functions. So we'll also need some functions while we actually make our project code. So we'll just come to here and we'll talk about that. Okay, so that's the idea about this one. So there is an example simply given here, max of 512.9. So the output you are expecting is what is the maximum value out of these three numbers. 12 is the maximum. That means highest value. So that's where we'll just get 12 as the output. Okay. So yeah. But also another important thing is you can go use the Terraform console and you can play with your function. So you can just go to the so Terraform console. All right, and you will say that, you go to the console, you can use any functions basically. So max of 5, 12, 9. So whatever you have there, 12 is the response, right? Upper of the string. So now I'll just say that, so sample, and you're going to get sample. Okay, like that, you can test out any function which is available out there. All right. So that's the idea about functions. Okay. Now coming back to the point, so we were using functions in, we were using some functions in validations now. All right. So let's come back to the validation. So here, this actually checking length of, length is what it's going to do. Length, what it is doing is length of not variable is not available. Like let's say length of so sample. Length of sample is actually happening is spelling mistake. Otherwise, it has to be 6 characters, right? So length of sample is 6. Length of sample is 6. Okay, you're getting 6 things there. Okay, so 6 characters there. Now actually it is your AMI has to be greater than 4 because it definitely starts with AMI hyphen. So it has to be greater than 4. There's the first condition which is happening there. And the second thing is so substring of so this one. Okay, so it actually checking it up. Substring, there is a function. Okay, now let's go and check it out what substring actually is trying to do here. And so it's actually under some string functions. So substring, what it is doing here. So substring, what it does is extracts a substring from the given string. Okay, that means what it's going to do, it's actually telling that substring of hello world, this one is actually is going to be, you're going to get that. Okay, so substring of this one. Okay, now let's say 0 to 4. If I say 0 to 4, that means starting with 0, you're going to get the next 4 characters. So you're getting hello. So what he is doing here, so substring of so 0 to 4. So that means he's taking the first 4 characters. It definitely has to start with AMI and hyphen. So that's a validation he's making. Okay, and if it is not correct, then what's going to happen here is it's gonna so throw a message saying that image ID must have the valid AMI and should start with this value. So this is what is gonna error up. Okay, so for an example, so if you want to validate any of such validations, you have this as available. All right, so let's try it out. So here this one variable image ID, and yeah, also if you provider okay. So now you are giving image ID. If I give blah 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 input, then it's gonna throw me an error saying that hey, the image ID must be a valid AMI ID, so it should start with AMI hyphen, isn't it? So that's how you're getting the validation. Okay, invalid value for variable. So now even though you can give it from command line, so hyphen var, so basically hyphen var AMI underscore image underscore ID, where image ID is equal to blah blah blah, still also it validates the same thing. Okay, so it is actually should be starting with this. So that's how you can put some conditions, or not conditions exactly, so validations when you take the input. Okay, so that's the idea. All right, so just to have some notes around here, so what we're actually doing here is, so variable to avoid the letter code failures. Okay, letter code failures, we always as a best coding practice. Okay, it's not only related to the Terraform, it's a best coding practice basically. Okay, so whenever you validate the input, okay, so first of all it should validate it properly, then only it should ask the input. So ATMs are the best example, right? So people talk about, but there is something actually involved out there, but still, so if ATM is not having the amount, actually it collects all your details. At the ending it will say that no amount is available. Okay, amount cannot be dispensable, right? So that's one of the funny part generally, right? So yeah, the same way. So probably, I mean, initially it should check that, so I mean, initially it should check that it can be dispensable the amount, so then only it will actually proceed with the transaction. Otherwise it should not proceed with the minimal transaction about collecting your PIN number and things like that. Also it should not do that. Okay, so something like that. Okay, so now when you write your code, so basically the first thing we have to keep in mind here is your inputs always should be in proper before proceeding. Okay, so to avoid the later code failures as a coding best practice, we always validates the inputs provided by user. Okay, so Terraform extends its support to do this in variables using the validations with the help of functions. Okay, so that's how. Okay, so that's fine. And so here it is how you have Terraform variable validations. All right, clear? Any questions? Okay, cool. So so the next couple of things which we have here is provisioners and data sources. Okay, let's talk about them as well. Okay, so Terraform provisioners. Okay, so Terraform provisioners, and so in the Terraform provisioner, so how it's actually going to happen. Yeah, so Terraform provisioners, so how it is actually what is the purpose of the provisioner is. So Terraform provisioners are used to provision, okay, so certain provision certain so commands, okay, so provision certain commands. I would say that provision certain certain tasks, I would say. Okay, task is also not right word, but still certain task. Okay, so after the resource creation, for example, okay, so connect to instance and perform some commands. Okay, so copy some files, okay, like this you will be doing. So Terraform provisioners are used to provision certain tasks or to execute certain tasks. Let's say execute certain task after the resource creation. So for an example, like connect an instance and perform some commands, or copy some files to the instance created, to the instance that got created, or something like that. Okay, so or even connect to the database and something like that. Okay, even okay, so this is how our okay provisioner will help. All right, so now like let's say I would say this. So provisioner is a subblock. Provisioner is a sub so subblock in resource. Okay, subblock in resource. So how does the provisioner look like? So provisioner in Terraform. We just go there, and you have different provisioners which are available. Now, what are the different provisioners which are available here is, so here is the generic provisioners is file, to copy some file. Local exec is nothing but wherever I'm executing the Terraform command. So here in this server, if I want to execute some command here, then I'll use local exec. Or I'm creating some server actually here, right? So I'm creating some server instance inside my my Amazon, I want to connect to that instance. I want to do something. Okay, so that comes as remote exec. Just destroying this. And also it can talk to some third-party provisioners as well. Chef as a all configuration management tools also it can talk. Ansible is not there because Ansible we can use a remote exec only directly. Or local exec also works with Ansible. To really have a separate provisioner. Okay, so Chef, Puppet, you have Habitat, you have Salt, you have different provisioners they are providing as well. So we don't actually use this. We actually using Ansible later. But for now, to start with, we are going to just use this. Now let's say our whole goal is so to create the infra and execute some shell script inside that, right? So the shell script is actually having some front end or something like that. It's actually having it. Okay, so that's how the provisioner will be there. So the provisioner purpose is to execute something after the resource creation. Now, how does the provisioner look like? Like let's say if I go for local exec, actually inside a resource, that's what I'm mentioning. Inside a resource, you're going to have a provisioner block, and you mention that particular provisioner. Okay, so the attributes inside provisioner will be so one important thing, resource attributes can be used. Resource attributes can be used. Resource attributes can be used inside provisioner. Okay, provisioner. Inside provisioner, you can what am I doing? Yeah, so Terraform provisioners and Terraform attributes can be used inside the provisioner. All right, and those should be referred as self.attribute. Okay, self.attribute. That's what is the very important thing. Okay, what I meant to say here is, now let's say if I go for remote exec, if it needs to connect to the remote server, so then it requires remote exec, and so in order to connect to that, so it require some public IP address, right? So it requires some public IP address, and the public IP address you are going to provide here is by providing some self.something. Okay, so I can just say that overview. It's not there here, and resource blocks. Sorry, this and provisioners, declaring provisioners. Yeah, you see this how to use some provisioners. So here you're having some self.private IP, self.public IP. So you're going to get that particular way. Okay, so the self object basically. So you see here expressions in provisioner blocks cannot be referred to their parent. So that means it itself cannot refer its own. Like let's say you're actually making the resource, it itself cannot refer its own resource. That's the problem. Okay, that's the reason you have something called as self. This came in, I think, Terraform 11 version, if I'm not wrong. Okay, until Terraform 10 version, okay, it was no self object was not there. It can directly use to connect, but after that something they changed it, and now it is all self object. So like let's say if you are creating an AWS instance, if you want to use to connect to the public IP, then self.public IP. Okay, private IP, self.private IP. So that's how actually it's gonna help you. All right, so that's what we are going to do. And the next thing is some quite important thing here is proceeding to that provisioner. Creation time provisioners. So basically this provisioner will happen whenever you try to create the resource, of course, but sometimes you need to make sure that so you need to execute certain commands before you want to execute some provisioners while destroying, basically while destroying. Okay, so that's where the destroy time provisioners also is available. Okay, so when equal to destroy, you will say. So when you're creating some resource, you want to execute some provisioners. When you're destroying the resource, you want to provision some more so some more provisioners. For an example, I'm creating a database. So while creating the database, I want to load the schema. So that's one provisioner. While I'm destroying the database, I want to dump the database into some backup. That's the destroy time provisioner. Isn't it make sense? While I'm creating the database, I want to load the schema into that. And while I'm destroying the database, I need some data, whatever it is there inside that particular one. I want to back up that particular one. Okay, and I want to store it somewhere. So I want to do something before destroying. So that's where destroy time provisioners also will come into picture. So when equal to destroy. So this is a quite important thing as well. So certain particular scenarios, it is really helpful. So provisioners are by default, so create time provisioners, and we can also specify destroy time provisioners. Okay, so this is a quite important thing. All right, so that's another thing which you have in provisioners. And you can of course write multiple provisioners in the same resource, no doubt in that. Okay, so let's make that particular point. So we can make multiple provisioner and provisioner types also. Provisioner types also in the same resource. Like let's say you have one local resource, you can make another remote exec also, local exec and remote exec also, and file also. Okay, so you can make multiple as well. So no need to be same type as well. You can make it multiple as well. Okay, so the next one is by default the provisioner will fail. Provisioner that fail will cause the Terraform apply itself to fail. On failure setting can be used to change this. So sometimes if you want to continue even on the failure also, it is possible. Okay, just keep that in mind, the behavior part. All right, so yeah, apart from this resource, this provisioners is sometimes really useful, and we are going to use them. Clear? Any questions? Okay, all right. So the next thing is data sources. And the last one and the very important one, which is the data sources. So data sources are used to refer the data of existing resources in the cloud. Okay, so in the provider, basically in the provider. Now let's say you're creating the resource. Okay, like let's say you want to find out the information of existing source, and you want to do that. Okay, so that's where you can go ahead and search the data by using data sources. So for an example, like let's say I think data sources Terraform. Okay, so you will easily get an example around the AMI. Usually an AMI is what generally are actually doing this. All right, so now here I'll say an example. Mm, 08 data sources. So provider AWS region US-east -1, and this is the one. So data of AMI most recent equal to true, and owners is basically whoever is the owner we are using to find the AMI, right? So for an example, now let's say I want to find out the CentOS AMI. So now let's say I can just go to the AMI section, and I'll say public images. Okay, now let's say if I say CentOS, there are a lot of images which are available. You can take some resource not owned by my public images. So there are a lot of images which are of so which are there by some people. So now let's say if I want to take their owner ID, so I will take the owner ID, or self means my account basically, but I'm just searching for someone else. And so here most recent equal to true, and you are actually getting so you will get some data. So now let's say output, and so AMI, so which is actually going to be is a data dot AWS AMI dot example. Okay, so whatever the data you get it, you print it. Okay, that's what I'm telling. And also it actually going to be AMI ID, right? So you get ID. So you're getting the AMI ID of this guy. So I think there's only one AMI, it seems. You're getting that AMI only. Okay. So, but like, let's say, so you see this guy is actually having multiple AMIs. Okay. So let me search for, so the owner is, I'm searching for owner is this guy. So he has a lot of AMIs. I want to get the latest AMI from this guy. Okay. So then what I'm going to say is I'm just going to give this ID and the latest AMI. So, and also while searching the latest AMI, you can search, okay, the latest AMI, which is related to some tagging. Actually, the AMI name is not given properly. So you will not get it as expected, but you have something here. Okay. You can filter with this. Okay. So I can just go for git space pull and Terraform apply, and then -auto -approve. So you got the new AMI. So this is the latest AMI from that guy. Okay. So like that, you can just go that. So now let's say if you are actually finding out my AMI, and you want to find out my AMI latest one. So you search for DevOps practice. My owner ID is, you are going to give some owner ID, and you give this, and you push that, and git space pull, just this one. Okay, so this you are getting the latest AMI is this guy. Okay, so you go and find it out. I have only one AMI, and you're getting it. All right, and so yeah, this plays a very key role actually in our whole automation. Finding the latest AMI. Okay, so that's it's not only about the AMI. Any resource you want to find out the data, you want to find out the subnets, you want to find out the VPC, you want to find out the instances, you want to find out the databases, anything, any resource, you'll be followed with some data sources as well. So now if you go to the Terraform registry, where is this? Yeah, not here. registry.terraform.io. So every resource you're going to find out both the resource creation as well as the data source as well. You see this? So every service you're going to have, like, let's say I'm just making EC2, I'm making the resources, and follow to the resource I have data sources also, AWS_AMI to find the AMIs. And like, let's say if I want to find out the spot price, then you will find out the spot price from here, whatever it is. Okay, so you'll find out the data and you can start using it. So that's the idea about the data sources, and we'll use this extensively in our coding. Now with this, all the basics are completed, and I will that's okay, I'll update the documentation later. So okay, so with this, all our pieces are ready of Terraform. So we are ready to so jump onto this particular diagram, and so we can create some servers, and okay, so we can create some servers, and we will just apply so just create the Terraform, just the servers, okay? And we'll not go with all the setup, so we'll just go with the existing setup only. The existing setup is the server creation should be done with Terraform and followed with the shell script to apply on the applied on the server. So that is one thing. And the second thing is, so probably we can just go with creating auto scaling row, creating the load balancer and everything, every piece also we can make it, okay? So it's up to us how do you make it. So yeah, whatever the way it is. So first we are going to start the Terraform, and we are going to make the, so first the VPC design, because the VPC is a quite important one. We'll design the VPC. On this VPC, we are going to go and set up this complete application infra. Okay, so that's the whole idea. I think that's all from my side for today. Any questions? Any questions?
Hey Raghu, has anything changed in your AMI? I mean, not in your AMI, in your image, the DevOps image that we use as far as the CentOS user is concerned? Because I don't know if I was using that yesterday, and maybe it's not got. I'm not able to do all the commands on CentOS user. I just need to probably change the permission set on it. Or I don't know.
You might be missing something, but my last AMI change was on October 29th. So recently no changes.
Okay. Yeah. So should I probably just go? It's not like allowing me to list. It's not allowing me to perform any function when I change the user to CentOS. So probably I just need to give those permission sets to it.
Yeah, ping me on Slack once what you actually are facing the issue so that I can explain you.
Okay. All right.
Right. Yeah.
Okay.
Anyone? Any other questions? All right, so no questions. We'll meet in tomorrow's session and we'll continue from there. Okay, thank you. See you tomorrow. Bye. Good day. Good night.